Now we are going to start with the Archimedes principle. So Archimedes principle states, first I will just dictate the statement for you. So it states that whenever body is partially or fully immersed in a fluid, that means we have a fluid in which whether we immerse the body partially or fully, obviously it is going to experience an upthrust. This you already know till here. Now we have seen that due to upthrust, obviously there will be a loss in weight. This also you know that whenever a body is fully or partially immersed, upthrust acts and due to which it loses its weight. Now the loss of weight is always equal to the weight of liquid displaced by the body. That means the apparent loss in weight is equal to the weight of the fluid that the body displaced when it is fully or partially immersed in a fluid. So in this that means we can say that apparent loss of weight is equal to upthrust, which is further equal to weight of fluid displaced, or you can say that upthrust acts due to which the weight is lost and which is further equal to the weight of the fluid displaced. Now we are going to see this with an activity. So for this we need few things. We need a Eureka can, we need a spring balance, we need a metal block or a cube, you can say metal cube, and we need one more can. So this is what is needed. So what we do initially, we just take a spring balance with the hook. The metal block is being suspended and we record its weight in air. Let's say its weight is W1. Its weight is W1. Now I just fill the Eureka can, as you can see that, and I am going to lower this thing into a Eureka can. So that means the spring balance is lowered into a Eureka can. So as the metal block moves down, some of the water gets you can say moves out and it is filled in this can. Let's say the weight of this was W1 in the air, and when it was suspended in Eureka can, the weight is W2. And you know that the weight which is in air, let's say W1 is a weight in air and W2 is a weight in water which is present in a Eureka can. So we have seen that obviously the weight in water is less than the weight which was measured in air. So that means the apparent loss in weight is equal to weight in air minus weight in water, because weight in air is more and weight of water the weight of metal block in water is less. So we have W1 minus W2. Now we have seen that, so this is the apparent loss in weight we can actually calculate. Now we have the water which like when we lowered it, the you can say a liter of water, few volume of water flows into this can also. So now what I do is I remove this can. Let's say this is my can, right? So it has water in it, the water which has flown actually when it was dipped. Let's say that water is this much. Now I am going to weight this water. Let's say its weight is W3. So it is being concluded and it is actually seen also that W3 is always equal to the apparent loss in weight. So that means loss in weight is always equal to the weight of the fluid that it displaces. So this proves the Archimedes principle. I think you got it. So that states when a body is partially or fully immersed, it experiences upthrust, due to which there is an apparent loss in weight, the bigger weight minus the smaller one, which is equal to the weight of the fluid displaced. This we have already seen that let's say the weight was W1 in air. When we lowered it, some amount of water flows into the can from this tube, and we have seen that the weight recorded was W2, which was always less than the W1. So apparent loss is W1 minus W2, and when we measure the water which was taken into the can, which moves out, that is W3. So we have always seen that W3, that is the weight of fluid displaced, is always equal to the apparent loss in weight. So this is what is the Archimedes principle.